now we are moving towards advanced course. So before we begin, I would like to introduce you about how the Swift as a compiler has changed from other languages, because this features something we are going to discuss today is more towards a feature that normally compilers doesn't use. So Swift as a language was designed to be have a very lightweight compiler and have lots of feature on the library itself. So while you are saying library, as a user or anyone, you can add more features like this. Like here is one condition, if else. If the first condition is true, then the first value will be written. If the first condition is false, then the second value is written. So it's a very basic fundamental principle, very basic function that such functions are not written in the compiler itself. It's a language feature. So the language can evolve with time. We can add more features. It's easier for anyone to go and code in library, and then we can enhance the Swift in the future. That's the philosophy that Chris Ladner had, and so hence the library is very much extended every year in Swift. There are lots of features added every year. So whatever we are showing right now is kind of how the library works, and these things are not in compiler. So if you are someone who has come from a language which has lots of compiler feature, this might seem too much overwhelming, but the thing is, this makes it easy to enhance the language more. So without any delay, let's see one very basic condition, the IfElse function, where the condition is taken and then the first value and second value is with the int type are taken as a input parameter, and output is also int. So here when you run the code, sometimes it's 100, sometimes it's 0. Basically, sometimes the bool random is true, sometimes it's false. So every time we run, we get a different output. So right now we are getting 100, and right now we are getting 0. So it keeps on changing. But the basically what I'm trying to show in this video is like the code can change dramatically. Let's change the code now. Just note that right now we have a long code, very long code, and we have to give condition, value, first, true, value, all those things has to be written down. But now what we can do is like we can sort it out. If we write underscore over here, the compiler doesn't require any parameter to be written over here, like conditions or value true, value false. This can enhance a lot in real life programming. Sometimes adding extra information about the param is very useful, but sometimes having a concise code is also important. So this is just the example. So here is also a tertiary operator where we just reduce the original code to one line. So it does the same thing, same code, same example, just it difference is like number of lines of code. So okay, we are discussing here about the argument labels, that is underscore. If we do this, we don't have to write the argument label over here. That's all. That's very simple one. But let's say tomorrow we need to add more features to the language, and the current feature of having only calculation of the int as a value of true or false can be very limiting. So what we can do tomorrow is like override the operator. What override does is like it can sometimes takes int, sometimes take string, sometimes takes double, and even take arrays. So let's take a string. So what this code does is like in the previous instance, it took the number int, but right now this code will be executed. You can see it over here, the 0. So this is how it works. The overload will try to match the exact definition from here and then call that code. So we can check this again, which of the code is called while we run this is again called, this time is 100. This is the particular code that's called because it's the string that has been overrode by the function. So no matter how many function you have, the only the corresponding correct one is called. This is called overload function. So soon this code will be very bulky and very hard to maintain because we don't know which code will be called and how many times we have to rewrite this. Every time there is a new data type, we have to keep on updating this. So what we can do for this condition is a very simple solution we have. It's called any. Any is in many languages very popular. and especially the languages which are not very strictly typed. But soon we will hit the issue and we'll discuss about that as well. First, let's see the example where the condition is bool again, no change on that part, but the value of true and value of false can be any. It doesn't have to be int, or it doesn't have to be a string or anything. But there is one small caveat. There is like as int. This is the force on wrapping. While we force on wrap, I know for sure that this code will work because this is int and this is also int. But let's say I come over here and just decided to do this. Because there is as int, the compiler doesn't care what over here or over here. It's anything can happen, so it doesn't really care. So while I run this, it will execute, it will run, but during the runtime there will be crash. That's the risk we have after using the any. The any is not a good compiler solution code to write, because any can run on this execution time, but while the code is running in real time, it will cause issue. So this is why the Swift is so strongly typed. We don't prefer doing any at all. So what's the solution to this problem where the language is not compiling and we need something generic? So that's called generics. That's why the function of all this video is to have a generic. Now let's go back to the generic, and if you have same code over here, instead of any we have a type T or V or something like that, any letters. While it does, what it does is like we have to define a type over here. That is generic, but the thing is both of these are same type, right? If this is int, this is also int, and this is also int. So if this is a string, this is also string, this is also string. So let me run this once and we can see. So right now it's a int value and this is running and this is all working good. But let's say no. So the thing is, right now the return type is also a string, because you can check over here, 10 is 10, and this is also string, this is also string, and this value, this definition of the value is also string. So that's how it works, and this is the beauty of generics. It won't crash the code. Not only that, it will be as powerful as using any, but even then, if it's any but we have the value type, what kind of it will be. So that's the beauty of it. Hope you enjoy the video. Come back soon for the more. Thank you.